Dear Chairman and audience, good afternoon. My name is Yu-Chen, and I'm very pleased to attend the 2024 IEEE Census Conference. And this is my topic, Monocular Camera and the IMU Integration for Pedestrian Trajectory Prediction. And this is my outline. And first, I will introduce the motivation. I think Taiwan traffic is very aggressive, and in the figure you can see the pedestrian accident. And the common main cause the accident is because the pedestrian not obey the traffic rule, or vehicle fail to give way to pedestrian. And when the accident happens, because the pedestrian lack of safety protect equipment, so always cause serious injuries. And in the right table, you can see our Taiwan compared with other Asia countries. We have a high death rate, and we even higher than the Japan 6 times. So want to early find the emergency dangerous. Some vehicle will use the autonomous emergency braking system, and the AEB system is use the camera and the LiDAR to detect ahead of the target and calculation the degree of the dangerous. But the American Automobile Association tests when the vehicle speed is to 32 km per hour. It can reduce the 40% collision. But when the speed went to the 48 km per hour, it almost happened the collision. So our goal is one to design a model can predict the trajectory as quickly as possible and combine in the AEB system to avoid the collision. And this is our paper surveys. The brain tree, the key of the future is use the CVAE to generation the trajectory. And it use the bidirectional GRU to predict the trajectory, and this can improve the model accuracy. And second paper survey is the PED format. The key of the future is use the multi-attention to attention the segmentation. And it use the transformer encoder combine the LSTM decoder to predict the trajectory and the actions. And this is our method. First, we use the camera to capture the Feng image, and then input the detection and tracking model to get the pedestrian bounding box and the person ID. And we use the bounding box to be our object trajectory. And we calculation this friend minus this friend to be our object speed. And then we combine the IMU sensor information and concat all the information input our GRU encoder to capture the temperature future and use the auto-regressive trajectory decoder to predict our trajectory. And this is our choose data set is pi data. We choose pi data set to evolution our model, and the pi data set sampling frequency is 30 Hz. So we need to observation the 0.5 second and prediction the interval 0.5, 1.5 seconds. And this is our predict trajectory model. First, we use the GRU to encode our temperature future, and we use the NLP to be our decoder, and we combine the auto-regression. The auto-regression is mean when I predict this friend, I will get the last friend prediction to be the this friend input information. And this is called auto-regression, and it can input our model's accuracy. And this is our experience result. The ADE is mean the average displacement error, and the FDE is mean the final displacement error, and is more smaller is mean the better. So our model compared with other baseline, we have outstanding accuracy. And we test our model in the GPU 4019. We have fast inference times. And this is our demo video. The blue one is our observation, and the red one is our ground truth, and orange one is our prediction. And this sense is the person cross the road. And this sense is person cross the road after the traffic light. And you can see we have high accuracy to prediction. And this is car turn in the corner. So first we will predict on the right, and when turn in a corner, we will predict on the left. And this is our conclusion. We decide this model is very light and have a fast inference times. And we use a GRU to capture the temperature future, and use the auto regression to predict the trajectory. And we evaluation on the Pi data set and achieve outstanding AD and FDE. And in the future work, we want to continue to optimize our model and reduce the more number of the parameters to devoid on an edge platform. And the TDF4, the AI performance is 8 TOPS. And our model just need to 4.3 gigafloat. And thank you for your attention. Do you have any questions?